be working. Okay.
Okay.
Yes. So just confirm with me if the screen is sharing there. Anything from that side?
Yes, I can see.
Can see. All right. So our topics for grade 12, we are having, normally other schools have already started, but since you are already writing in June, which means we will be treating past exam papers. That will be the strategy. I don't know if the theory is already fine. You need to go back to the theory, because also when you are dealing with past papers, the theory, especially paper 2, organic molecules, is very important when you are dealing with the past papers. So if the theory is not that much good, that's when sometimes you find it difficult for you to master. So for today, we will start with the chemistry, just the basics, since you said paper 2. Is it fine?
Yeah, it's fine.
Okay. So if we have some questions in particular, which you would want me to assist you with, since you know you've set for an exam for grade 12, so you already know your weakness, that I have weakness in these areas, you are free to send the question papers to say, let's discuss this question paper. How do you go about it? But you must send it before, so that if I had planned something on that day, then I cancel what I would have planned to share with you. Then we focus on what you want me to assist you with. So normally you must send the work or the question paper that you want us to work on before our session. So which means this weekend, you can even compile your things which you want us to discuss starting from Monday to Thursday. Is it fine?
Yes, it's fine. I had read my paper to the theory. I'm not good at it.
Which one?
Paper 2.
Yes, paper 2, that is the chemistry side, isn't it?
Yes.
So we'll try to assist you with the chemistry side. That's what I was saying. So today is just a session where I'm just familiarizing you with how we are going to be working, and then etc., so that you see how we are going to be working. So let's have a question which we can start. Yes. We have a question which we can start working on for chemistry. For organic molecules, which is chapter 4. So these are organic molecules. So normally that's what they do in term 1. Term 1, organic chemistry and etc. All right. So these are just good terms which are there for multiple choice problems. I will share with you after the end of this session. So by now, we are just discussing, when you talk of a homologous series, the definition, which means a series of organic compounds. So these questions, they come on multiple choice. So I will share this table with you. So the theoretical definitions are simplified, so that even in a test or exam, you are able to remember. So when you talk of homologous series, for example, alkanes, when you are talking of alkenes, okay, so this is a series of compounds that are described by the same general formula. So we are going to be having a same general formula for alkanes, same general formula for alkenes. So that is a homologous what? Series for the first part when you're talking of homologous series. Or in one member differs from the other with a CH2 group. Okay, so this is one of the cases how they are going to be differing, so that you can see whether it's a homologous series. But the simplest definition is that they have the same general formula. Homologous series, these are organic compounds. organic compounds. What do we mean by organic compounds? Organic compounds, which means you are talking of carbon, hydrogen, nitrogen, oxygen. So we don't want to see any other compounds which are not organic. So those elements are the ones which you should see on the formula, chemical formula of any compound. Then we are having a functional group. When we talk of functional group, these are the definitions which are there, which I said I will share with you. Okay.
Okay, sir.
Because this one, they want you to read and prepare. We can't be discussing these ones online, things which you can read on your own. So I will share the note.
Um, I wanted to say my main problems are on acids and bases. Acids and bases, the redox reactions, um, maybe chemical change, but I do try sometimes. And the electrochemistry
Yeah,
part.
on the electrochemistry part. So when it comes to this side, you find the
Yes,
organic part.
yes, you can maybe like give me send like some questions as a test, so you could like maybe test how far I am with the topic, and
Or
then
your challenge is the what you said. Okay,
uh,
this one. Okay, as I will be scrolling. We are just browsing. We have not yet started, isn't it? It's just you are
yes,
refreshing the memory, isn't it? You are refreshing your memory. So
yes,
these are basically the alkanes, and then we are having the general formula, which is given by
and two.
CnH2n plus 2. This is the general formula for
Okay,
alkanes. Then for alkenes, where it differs by
eight.
CnH2n. Yes. So each homologous series has its own general formula. That's what we've been talking about. And then now we are about to name, if they're having 5 carbons and 12 hydrogen, then what name do you give it to this hydrocarbon? What name do you give to this hydrocarbon? This one.
Pentane.
It's pentane because of the number of carbons. And then what about this one? What name will you give it? If it's
Hexane.
hexane, yes. So which means there for real, you know these things. Okay, we are just refreshing the memory. So the structure, the name. So there they are showing you that for alkanes, the structure is having single bonds bonded together. Okay.
Yes,
And then for the smallest which you can get for alkanes, we said it's what? It's methane.
methane.
Methane, that is the smallest which we can get, which is 1 carbon atom. So it will be methane. What about for alkenes? The smallest that you can get is what? Do you have methane? Does
Ethane.
this,
Ethene. Ethane.
does this one exist?
No, it doesn't.
Doesn't. Yes, yes. So yeah, there. So the first one, it will be ethene with an
With the
E.
ENE.
Yes, ethene. So which means this one, there will be two of them, two carbons bonded with the. So how do you know they are alkenes? Because of the double what? The double
Double.
bond. The double bond. So the carbon to carbon double bond.
Mm.
Is that correct? Yes. So this one, today's session, we said we are just refreshing the memory. Then you see how we are going to be working. When it comes to the real questions, we'll go to those ones which are specific. So alkynes, they just have a double bond. I mean a triple bond.
Oh,
So
bond.
methane, butane. So the name ends with a what? YN
And
E. So the name there it will be ending with a YN E.
E.
Yes. So how do you see that it's an alkyne? Because of the triple bond. Okay. Then we are going to be having also other compounds, organic compounds like haloalkanes. So whereby the terminal atoms are group 7 elements. For example, chlorine, bromine, iodine, fluorine, chlorine, bromine, iodine. So those, once they are there as terminal atoms on the hydrocarbon, which means it becomes a halo alkane. From halogens are group what elements?
Group 7 element.
Yes.
It's a group 7 element.
Group 7 elements, yes. Before the noble gas, before it becomes a stable octet, 7 electrons in the outermost shell. So group 7. Okay. Then alcohols, how do you know that's an alcohol? Because of the branch, the OH branch.
OH.
The OH branch, isn't it?
Yes.
Yes. So whenever you see an OH, then you know it's a hydroxyl group, which means I must form a what? An alcohol. So these are the things that you should be knowing by head, and I will share with you as well after the meeting so that you can have them or print them. So I advise you to print these things and avoid using a phone, because things are a lot on a phone, and when you go to exam, you remember what you were touching for a grill. On the phone, the memory is very poor. So you rather print your things out so that you can work with printed things, hard copies. The memory can remember what it was touching and seeing. Unlike what you have been scrolling, it's very difficult to remember.
Okay.
So for aldehydes, which means we are checking the COH bond, the COH bond. And how do you know that? Always between the bond between the carbon and the oxygen, it's always a double bond. So that's how you check whether it's a aldehyde. And here, the bond between a carbon and oxygen, it's a single bond. So already when you see it like this, then you know it does not fall in that group. Okay. And then we have ketones, for example, propanone, butanone, hexanone, pentanone, etc. How do you see it? It's not having a carbon which is attached to a hydrogen. We are only looking at the CO bond. Yes, the CO bond only. But for the aldehydes, which means the COH bond. And for the alcohols, they are only looking for the OH bond. So those are the things that you'll be looking for on an organic compound before you name it. And then therefore the carboxylic acid COOH bond. So you know if I have a CO bond, I'm just talking of ketones, propanone, butanone, carboxylic acid. So we are talking of methyl butanoate, so carboxylic acid. So you check for the COOH bond. So that's how you identify those. It's just refreshing the memory. Then the esters.
COOC.
So you check whether it's a methyl pentanoate, which means you are forming esters. So I will share as well how are esters formed, which reactions they form esters as well, which are simplified for the organic reactions. Okay, so that's where all the organic chemistry lies here on this page. So first they will tell you this reacted with that, what is the name of this compound, what do you produce? Those are the only things. They don't go deeper more than that when it comes to organic chemistry. So yes, the aldehydes, we have attempted those ones. So now we are talking of the branching, the side chains. You read or you name according to the number of or the longest chain, etc. Okay. So this is what is being represented. There is a branched structure, which is here on the left, and we have a straight structure, which is the longest structure. So when you are naming this, you name according to the longest, where you have branches, which is the longest chain. You start naming from the branch with them. So on the left here, the branch chain, which one is the longest chain is how many carbons? If you are to look at that one, how long is the longest chain? It is how many carbon? This one on the left. The longest chain is how many carbons?
They are equal.
Are you sure?
Yes.
Equal with how many carbons?
Oh no, the longest chain is the one with is the one on the right.
Is the one on the right.
Yes.
The one on the right, it is how many carbons?
It is 2 carbons and then branch.
No, I mean how many carbons in total? These ones on the right. How many of these ones on the right? Carbons. How many are they? On the straight chain.
7.
There are 7, yes. Then on this side, how many carbons are you seeing on the longest chain on the left side? How
5.
many? There are 5. So any route that you choose, the longest chain is going to have 5. So the other ones, they are going to be substituents, which are branches, which you are going to name, which means it's attached at which carbon. So which means there is a methyl group, which is CH3, which is attached to that carbon. And also there's another methyl group, which is attached to that carbon. So it will depend where are you going to start numbering, naming the carbons. If you are going to start from the left or you are going to start from the far right, but make sure you use the smallest numbers. So if I'm to ask you, give me the name of this compound, which is on the left. Let's just see how your chemistry is. Which side are you going to start numbering from? Are you going to start numbering your carbon number 1 from this side, from the right? Or are you going to start numbering your carbon number 1 from this side, from the left?
Um, I'm gonna start from the left and say
From,
2.3.
yes. So which means from the left, which means this is carbon number 1, isn't it?
Yes.
This is carbon number 2, carbon number 3, carbon number 4, carbon number 5. So what will be the name of this compound? And remember, we have 2 side chains. We are having a different group of chain, which is this one, the CH3 chain, the methyl group, and we have another methyl group there, the CH3. The longest chain is 5 carbons, and you said you are naming from carbon number
1.
number 1 from the left, because if you choose from the right, your numbers are going to be 1, 2, 3. So the side chain will be number 3 and 4. So if there is a route where we can eliminate big numbers like 3 and 4, and we can use maybe, for example, 2 and 3, we choose that shortest route, isn't it?
Yes.
So give me this name of this compound. What is the name of this compound? This one.
It's 2.3 dimethylpentane.
Yes, 2.3 dimethyl pentane. Yeah. Yeah, right. For real organic, yeah, good. Yeah, good at that. I can see. That's correct. So we have chain isomers, and then we have the 3 types of structural isomers, the chain ones, the positional isomers, which means they have the structural formula. Structural isomers are 2 or more organic compounds. Yeah, 2 or more organic compounds that have the same molecular formula but different what? Structural formula.
Formula.
Yeah, so there in organic chemistry, they will be busy mentioning the structural formula, the chain isomers, and the position isomers. So we'll be also dealing with those kind of problems.
The, I have a problem with the positional and chain isomers. At
Or the
times,
position.
I'm not preferring
Yes.
them.
Okay. For example, a positional isomer. These are isomers where position or functional group or side chain is changed on a compound, for example, is changed on a compound, for example. All right. So which means here the learners can see that the double bond has been moved from the first carbon. So check the position of the double bond. It has been moved from carbon number 1 to carbon number 2,
True.
which means they are not naming from this side to say 1, 2, 3. So which means if you name from either side, it's still the double bond is still at carbon number 2, whether you name from the left or you name from the right. The double bond is still at carbon number 2.
True.
Yes. So the double bond has changed its position. Hence, it's a positional what? Isomer. Meaning that these two alkenes, they have the same general formula. This we're saying the same molecular formula. This is the same molecular formula. So the molecular formula, you seeing that is the same. At the end
Yes.
of the, we are having C4H8.
8
But the position of the what? The double bond is not what?
is
The
not the
same.
same.
That's why those two are positional isomers. So you'll be now naming that what is the name of number 1? If I'm to ask you, what is the name of the one which is on the left? The one which is on the left, that alkene which is on the left. What do we call this alkene which is on the left?
Um,
First, the trick, you count how many carbons, isn't it?
But one in
Carbon number 1, which is one what?
but one butene.
Okay, you want this way. 1, you can call it 1 butene, like
But one
this.
in
Or you can call it but1ene, isn't it? For example, but, then you put a hyphen, then 1, then you put what?
in
Meaning the position is at what? At carbon
one
number 1. Then the
one
other one, it will be what? You can call it 2-butene, or you can call it what?
but two in
Yes, or you can call it but2ene, meaning those two, they are position isomers, but I mean they have the same molecular formula, but they are what? They have different structural what? Formula.
uh,
Means the position of that bond, the double bond. That's why they want, it's an isomer positional. Now they are being specific. In what sense? The position of the double bond. If it was an alcohol, the position of the OH bond. If it was an alkyne, the position of the triple what?
bond.
Bond. Yes. I think you have been answered there. Then the functional isomer, these are isomers where the functional group or molecule has changed. In other words, the compound still have the same molecular formula, but belong to a new homologous series. So we are still having the same molecular formula, but it now belongs to a new homologous what?
Series.
Series. So instead, it's not following to the same homologous series, but we are having the same what? Molecular formula. But those two compounds still have the same molecular formula, but belong to a new homologous series. So there are two sets of functional isomers that can be identified, which means the number 1, carboxylic and esters. So you can see that this one is still the same molecular formula. Can you see this one and this one? So they are functional isomers. Why are they functional isomers? They have the same molecular formula, but they belong to different what? Homologous series. Yes. So the other one, it's an carboxylic acid. Then the other one, it's an ester. How do you know that The name of carboxylic acid end with what?
COOH.
Any example of a name of a carboxylic acid that you know?
Butanoic acid.
Yes, butanoic acid, methanoic acid, etc. And then what about an ester? Any example that you know of an ester?
Ethyl propanoate.
Yes, ethyl propanoate, etc. All right, so I have a class at 10:50 for grade 11. Normally, we have to decide when are we going to have our classes now from Monday to Thursday and the time. And Monday to Thursday, it's only online where we'll be discussing live like this. However, if you have other problems where you need to text via WhatsApp, still I'm available. I'm not closed. But only for live sessions where you can ask questions and I can respond directly. This is what I was saying. Only Monday to what? Thursday. But if you have another question, suppose you want to text it on WhatsApp, still I can respond if I'm not busy. But the time where we have sessions Monday to Thursday, 1 hour session. So you decide on time. If you feel like later night is better for you compared to afternoon, you tell me.
Okay, I'm still gonna look at which times I'm available at, because currently I'm mostly busy during the day and available from the time you scheduled yesterday.
Yes. So that's what I was saying. If perhaps you would want it late night, you tell me that late night, this time to this time. Then
Okay.
we, yes, then we know. If it's 8 to 9 or it's 9 to 10, then we know. So that we don't put you along the schedule where you'll be busy, still busy rushing.
Okay.
All right. So that was just a recap of how we are going to be working. So I will send the banking details. We said it's 500 per month, isn't it?
Yes.
So I forward you the banking details. Then Monday session will start. The time you let me know.
Okay.
Starting tomorrow. Yes. If you have some specific questions which you want us to work on Monday, forward them before so that we can be picking from yours. We add more and we can prepare notes that can make the process to be more effective.
Okay.
All right. So let's stop here for now. We'll continue.
Okay. Thank you.
All right.